We looked at the 5 different kinds of cells in the epidermis. Let's look at the layers or strata of the epidermis. There are 4 or 5 layers depending on the degree of friction and mechanical pressure applied to the skin. So some areas of your body have 4 layers of epidermis, other areas of your body have 5 layers. We'll see which ones those are. From most superficial to deepest, remember these are terms we know now, so superficial would be what you might think of as the top, deepest would be the bottom, the deepest inside. We have the stratum corneum, the stratum lucidum, which is only in the palms and the soles of the feet, the stratum granulosum, the stratum spinosum, and the stratum basale, which is sometimes called the stratum germinativum. All right, either one is okay with me. Now, you actually do have to know the 5 layers of the epidermis, and you have to know what order they're in, and you have to know which one is on the top and which one is on the bottom. So, one little thing that I've used in the past to help myself remember this, the exact order, I remember that Cora Lucille's granny spins baseballs. Now, I'm aware that that doesn't make any sense. And sometimes, actually, when you make up little memory tricks, the goofier they are, the easier they are to remember. So in this case, I like it because each one of those words sounds similar to the layer you have to remember. So Cora, corneum, Lucille, lucidum, Grainy, granulosum, spinosum, and baseballs, basale. So there you see Cora Lucille's granny spinning the baseball, okay? Yeah, it's dumb, it's stupid, so what? I don't care. I'm dumb and stupid too, and those are the kinds of things I have to do in order to keep this straight in my own head. So use it if you want to, or don't if you don't want to. This is America, damn it. You get to do whatever you want. Let's now take a look at the layers, but this time let's start at the bottom and work our way up. So the first layer, the stratum basale, why is it called basale? Because it's the base layer. It's the base layer. It's the bottom. That's where you get the word basale from. It's the deepest single layer, also called the stratum germinativum. It's got tactile cells, melanocytes, and keratinocytes, and stem cells that divide repeatedly. So look at the cartoon there on the left. You can see that bottom dark layer, the stratum basale. Notice it's a lot of stem cells, and then they're dividing and making keratinocytes and melanocytes, and that's also where the tactile cells show up. See there on the right, the tactile cell? As we mentioned before, that's right at the boundary between the dermis and the epidermis. This base layer forms epidermal ridges, which create fingerprints. So we'll see later that the dermis underneath, there's an underlying layer called the dermal papillae, and the dermal papillae are these little nipple-like structures. Papilla in Latin means nipple. And the epidermis conforms to those, and that creates ridges. And those ridges are what form your fingerprints, okay? So there you see it. If you zoom in close, what we're seeing there, those different ridges you can see in the close-up, those are epidermal ridges, all right? And that's the outermost layer then. That's the stratum basale, rather. The stratum basale is deep down. It's conforming to the dermal papillae, and it's creating those ridges. And there in the picture in the bottom left, you can see actually the pores of the sweat gland ducts, bringing water up to the surface to cool you down. Next is the stratum spinosum. It's called spinosum because it's spiny. Spinosum, spiny. Provides strength and flexibility to the skin. All right, it's a deep layer, so it's giving structure. It also has a little bit of give to it, so your skin can bend. 8 to 10 cell layers. So remember, the stratum basale is only one layer. Now we've got 8 to 10 layers of keratinocytes. During slide preparation, you know, if you want to look at things under a microscope, you often have to stain them, otherwise you can't see them. So what happens is during the preparation, the cells in the stratum spinosum shrink up, and they look like they have little spiky spines all over them. So that's why it's given that name. They don't normally look that way. They just look that way when you're preparing them for view under a slide. This is where melanin is taken in by the keratinocytes, okay? So notice if you look on the cartoon on the left, the 8 to 10 layers there, you can see all those little dots all over the place. Yeah, that's where the melanin is being taken in by phagocytosis from the nearby melanocytes. And there are also lots of dendritic cells. Remember, they're wandering around in here. They're macrophages. They're eating up bad guys and then displaying them on the surface. You remember what kind of cell that was called? an antigen presenting cell, an APC. They are at the very heart of your immune system. So keep that in mind. You'll see those a lot in biology. Let's look next at the stratum granulosum, the grainy layer. Right, that's why it's called granulosum. It's got granules, it's grainy. This is the transition layer. So the stratum basale and stratum spinosum are still, stratum basale, of course, is where the stem cell division is taking place. The cells in the stratum spinosum are still alive, and in the stratum granulosum, they're starting to die. And you might think, what, die? My own body is dying? Yes, and it's dying intentionally, all right? So these are 3 to 5 layers of flat dying cells that show nuclear degeneration. That doesn't mean like atomic bombs. It means that the nucleus of the cell is degenerating. This is something you should have seen before. I hope you did. But if not, that's okay. Apoptosis, it's called. Usually the trademark phrase they use in all the textbooks is programmed cell death. I have people in class, I say, what's apoptosis? And somebody raises their hand and I say, yes. They say it's programmed cell death. And I go, yes, you're right. Now what does that mean? They go, So what this means is apoptosis means cells die intentionally. It's, in a way, it's like cells commit suicide, but they do it intentionally. Why do cells kill themselves intentionally? Well, remember, cells have a lot of stuff inside. Lysosomes, for example, full of harmful, dangerous chemicals that do recycling. And if cells just die randomly, if you just, smash them and they burst open, then all kinds of dangerous things can come on out. So apoptosis is a way of the cells dying in an orderly fashion so that they kind of consume their own organelles, and that way you don't cause chaos within your body. There are also lamellar granules that release lipid that repels water. This is where keratinization begins to occur. This is a good word, and I want you to know what it means. It's very easy. Keratinization means the cells fill with keratin. So, remember the keratinocytes are the living cells, all right, made by the stem cells. But at this point, as they die, as they intentionally die via apoptosis, the cell contents are replaced with keratin. So now the cells just become dead packages of keratin, which is exactly what we want. This is now going to protect you, and you don't have to worry about harming these cells because they're already dead. They're already dead and full of tough keratin. So who cares if they get hurt? Their purpose is just to protect you, and they'll do a good job of it because you can't really damage them. So the stratum lucidum, lucid means clear. This is the clear layer. This is present only in the fingertips, the palms of the hands, and the soles of your feet. Can you think of why we might have an extra layer of cells in the palms and the soles of your feet? I ask this question in class, and usually somebody starts frantically waving their hand because they're very excited. And I call them and they say, yes, it's because we walk on the soles of our feet, and all throughout the day we pick up things and lean against things, and we're using the palm of our hand. And I say, no, that's not it at all. And they have this shocked look on their face, and I go, I'm just fooling. Yes, of course that's why. It's because we interact with the environment with our hands and our feet. So we have an extra layer there to provide extra protection. Makes sense, okay? 3 to 5 layers of clear, flat, dead cells. And then on the top, the stratum corneum. Corn means horn in Latin. This is the horny layer, not horny the way you're thinking, you people with dirty minds. Horn like the tough horns of a cow or a rhinoceros, remember, which are made of keratin. So this is a tough, horny layer on the outside of your body. This is 25 to 30 layers. So in the diagram, notice, look at the difference between the stratum spinosum and the stratum corneum. In the stratum spinosum, there are still big round-shaped cells. Look, at by the time you get to the stratum corneum, they're all squished and flat. Yeah, that's because they're dead and they're just full of keratin. And that's their only job at this point, is to protect you from damage by being dead things full of tough stuff. That's how they protect you. They're continuously shed, and they form what's called scurf. Is that a cool name or what? So, like every time you scratch your arm, thousands of keratinocytes from the stratum corneum flake off through the air and fall down onto the surface. So, As you may know, like when you see a layer of dust on top of people's furniture, some of that really is dust, a lot of it's just carpet fibers and other stuff, but some of it is actually dead skin cells. So we have fun sometime. Go over to somebody's house and like run your finger through the dust on the surface of their furniture, and then stick your finger in your mouth and go, "Oh, Jennifer's been here." And then see if they wonder how you know what Jennifer tastes like. Might start a fist fight. Can be fun, very entertaining. It's a barrier to light, heat, water, chemicals, bacteria. Again, 25 to 30 layers of flat, dead cells full of tough stuff. And so, yeah, it protects you. Lamellar granules still full of lipids make it water repellent. And constant exposure will cause a callus, which is a thickening of the epidermis. That's all that is. So like I play the guitar, I've got calluses on the tips of the fingers of my left hand. Those are from holding the strings down. If you go to the gym and lift weights, you'll get calluses across, the inside of your palm there, right on the other side of where your knuckles are, from grabbing the weight bar. If you work outside with a rake or with a shovel and stuff like that, you build up calluses on your hands. It's just because with constant use, your body's going, oh my gosh, we're using this area a lot. Why don't we make it tougher? All right, and that's what a callus is. So you shed roughly 50,000 cells per minute. An entire layer is replaced in 2 weeks. So the stratum corneum, not the entire epidermis, but just the stratum corneum, replaced about every 2 weeks. So that's how fast the cells are flaking off, and that's how fast you're replacing them. You need to do that because that's the whole purpose. Keep losing cells. They're expendable. They're disposable. Doesn't matter if they get hurt. They're already dead. Just flake them off. So keratinization, remember, do you remember what that means? I might ask you this on a quiz or an exam. Keratinization means the cells fill with keratin. So easy. Keratinocytes are produced by dividing stem cells. As the keratinocytes are pushed upwards towards the surface, they fill with keratin. That's what we just watched, all right? Going from the base layer, all right, then through the spinosum, into the granulosum, into the lucidum, into the corneum. Cells are dying as they work their way up. They're filling with keratin. They're flattening out. That's the whole idea. That's the way it's supposed to work. Keratinization is the replacement of cell contents with the protein keratin. It occurs as the cells move to the skin surface over 2 to 4 weeks. You shed your entire epidermis about every 6 to 8 weeks. So we're starting this class the first week of June, so let's go back May, April. So like in March, none of the cells you have in your epidermis right now were there in March. You've replaced all of them. Isn't that cool? And again, that's the way it's supposed to work. Your epidermis is expendable. You just shed that stuff. That's great. Doesn't matter if bad stuff gets in there, you just shed it, okay? They also produce vesicles filled with a lipid mixture, again, that waterproofs your skin, tries to keep you from looking like the Pillsbury Doughboy. And epidermal growth factor, other hormone-like proteins as well, play a role in epidermal growth. Growth factors are really important in the human body. A lot of research on these in recent years. Nerve growth factor, insulin-like growth factor. Growth factors are hormone-like substances that regulate growth in the body. So they're a big deal. A lot of studying that, trying to figure out exactly how we work. Epidermal growth factor produced by salivary and duodenal glands. You can actually use that in laboratories to grow skin grafts. That's one of the cool things they do now. People with burns, you can use epidermal growth factor, and it will cause you to grow big sheets of skin that they can then layer on top of your body and replace skin that burned away. Okay, that's it for this one. We'll pick it up again in the next annotated PowerPoint.